Hey guys, it's Mrs. Gregerson, and as I promised, I'm going to work some problems out for you from lesson 11-2. And the first thing I want to work with you is on the homework supplement, just to remind you of a few skills that you're going to need. First of all, just review of a lot of key things, like how do you find the area of a regular hexagon. Remember, you draw the central angle triangle, which is one of the 6. This would be your side length. Remember, your apothem, they tell us, is 6 meters. Remember, you have to use your central angle, which would be 60 degrees. Your apothem would bisect it, so that's a 30, 60, 90. You realize that you have the long leg of a 30, 60, 90 triangle, so you get to the short leg, and you remember you divide by √3. So you end up rationalizing the denominator, ends up being 2√3 when you're done, which means my other segment right here is 2√3 because the apothem also bisects it. So your side length is 4√3. So your perimeter is 6 times 4√3, which is 24√3. So then we just plug into our formula. Area equals apothem times perimeter over 2. The rules still hold the same. You write down your formula, you put everything below. Your apothem was 6. Your perimeter was 24√3 all over 2, and it should be 72√3 square meters when you have it done. And this is the segment of a circle. This is still one of the hardest ones, but remember, if it's a triangle and your central angle is 60, and you know it's an isosceles triangle, these other ones are also 60, and so it's actually really quick to find this one because it's the area of the sector minus the segment. So the area of the sector, minus the triangle to get the segment. So the area of the sector is m over 360 times pi r squared. So my m is 60 degrees. It's the degree measure of the arc. My radius is just 4, so that's squared. That's 1/6 of, and we have 4 squared is 16 pi. So that reduces down, because you can take a 2 out of each, 8 pi over 3. Now, the area of the triangle is really easy. It's an equilateral triangle because of the 60-degree triangles. We know all the sides are the same. And you can just use side squared √3 over 4. So 4 squared √3 over 4 is going to be 4√3. So my final answer for the segment is 8 pi over 3. And I know that's written real sloppy, but I'm not going to take the time to white out today. Minus 4√3 square meters. So that would be your final answer. All right, and then my other biggest thing is the trapezoid, is make sure you have the right formula, and I'm not too really worried about that, is make sure you draw on your height so you make a 45, 45, 90 triangle. And once you do that, you'd realize these two sides are 5. This segment would be 6. So this whole base would be 11. So your base would be 6, your base would be 11, your other base would be 5, and then you just plug and chung it. I guess I'm going to finish the problem anyway. I can't help myself. It's fun math. So you get 6 plus 11 times 5 all over 2. So we end up getting 17 times 5, which would end up being 85 over 2 square meters. So that's the area of the trapezoid. Big one for number 4 is make sure you remember the radii of a circle are congruent. If you realize that, then you know you have a 7, 24, 25. So to get to x, you just have to go 25 minus 7, which is going to be 18. So not degrees, just 18, because it's a Pythagorean triple. If not, you could factor it. I forgot to write the right angle. Everyone should be yelling at me right now on the top of your lungs, like, Gregerson, you didn't mark your tangent. Apologies. The next one, number 5, is kind of unique. It's a reminder of alternate interior angles and corresponding angles with parallel lines. And I'm going to show you, I think, the easiest way of solving y. There's 2 different ways. One way, which I'm not going to use, is you can actually just go ahead and extend one of these to make it a complete transversal. And you can use it that way, because if you did, your 44-degree angles would be 44 here, and you go 44 plus 52 is going to be 96, and that's going to be y. Or one way that I've seen done before, and I like this way, it's fun because you can visually really see it, is to draw a parallel line that is parallel to the other 2 right through the vertex of that angle. And the instant you do that, you end up getting alternate interior angles that are congruent. So if this one's 52, this one would be 52. If that one's 44, that one's 44. Y ends up being 44 plus 52. It's 96 degrees. So I like that one a lot. All right, now the next one is they have two parallel chords, so we know they are parallel, are each 24 centimeters long. The distance between them is 10, so both of these are 24. The distance between them here is 10. It says find the circumference of the circle. Now here's a few things you need to remember. Remember, chords that are the same size are the same distance away, so I know those two are both the same, so they're both 5. Now, and we're talking about the distance, we're talking about the perpendicular distance, and so that means this segment right here is 12. If we want to find the circumference, we need the radius, so I draw in the radius to the end, and I get a 5, 12, 13 triple. So my circumference then is just 2 pi times the radius, so it's 2 pi times 13, so I get 26 pi centimeters, and that would be the circumference. But here the key, remember, is drawing from the center to the end of the chord. All right, and the last one here, because I think this is important for us to get, says write the equation of the perpendicular bisector of a line segment with the endpoints 4, -5, and 10, 7. So remember, it's kind of like this is the idea of the diagram. Here's 4, -5, and way over here you have 10, 7. And remember, I want the perpendicular bisector, and a perpendicular bisector forms a right angle and it goes through the midpoint. So we have to write the equation for that. So first of all, you find the midpoint. It's the average of the x's and it's the average of the y's. And so you should end up getting 7, 1. Should be your midpoint. And then you should find the slope of your given line segment, because then we can use the opposite reciprocal to find the slope. So find the slope of the segment, so we're going to go change in y, so 7 minus a -5 over change in x, 10 minus 4. You're going to go the same direction. We get 12 over 6. Oh, that's 2. But I want to be perpendicular to that, so that's going to be a -1 over 2. I forgot my 2 there. That wouldn't be good, would it, guys? Totally wrong problem. All right, so then here's my slope. Here's my point. All I need is a point and a slope. I didn't say what form, so we can put in point slope form of a line. So we get y minus 1 equals equals a -1/2 x minus 7. All right, I hope this helps you on 11-2 homework supplement. I'm going to quickly grab, looking through the book here, I'm going to get the calendar out. I'm in a little chaos tonight. It took a while to get some things figured out. On your homework for 11-2, I'm trying to see if there's some good questions that we should look over. I wish I had some of you screaming at me. I always appreciate a little bit of direction on here. I think you were supposed to do 1 through 18 all, 21, and then we had 30 through 32 all. So I'm trying to look through anything that's 1 through 18 all. Just trying to reiterate a few things to remember that will help us. And so I'm just going to throw just an example quickly of one, and then I'm going to do a couple of the other ones I think will be helpful. More like 17, 18, 19 would be probably some good examples. Few things you need to remember. So let's look at number 8, okay? When you have two circles, okay, and we talk about coming from the center, and I'm perpendicular to the chord. Radius, it's going to be part of a radius or diameter. We know it's going to bisect the chord. And so here we have a diagram on number 8, and we know, oh, they're both perpendicular, so I know they're bisected. But here was the other additional piece of information. They say, I want to know x, which is the whole side. But they told you they're the same perpendicular distance away. If they're the same perpendicular distance away, the two chords are congruent. Well, they told me this segment was 5, which means that one's 5. So what's the length of that whole chord? 10. Well, that means if they're the same distance away, x is equal to 10. And that's just a rule you have to have memorized. Now, we could prove it using, isosceles triangles and, everything, but basically, that's the rule you have to know. And if you're going to want to get these right, you always draw your radius to the end of your chord, and you're going to form these right triangles every single time. So remember, if I draw a segment from the center that's perpendicular to a chord, it will end up bisecting the chord, and it also will end up bisecting the arcs and stuff as well. I just think that's like some of the coolest thing you can do. All right, let's look to see a little bit more here. I'm trying to think about which one would be another good example for you. Oh, let's do like one number 14, okay? This is in your book on lesson 11-2, number 14 on page 593. On number 14, and I promise you this will show up on the ACT, a problem similar to this. They give you a chord that's 22 units long. They tell you that from the center, there is a perpendicular segment that is 6 units long. And then up here, floating around, they have a radius that's x. Well, I'm going to tell you, up there, floating around, the radius being x does absolutely nothing for you. Okay? Instead, what you do is you redraw the radius coming down to the end of your chord. So you form a right triangle. And you also use the fact that if I have a segment from the center that's perpendicular to a chord, it bisects it. So this is 11. Oh, look, I now have a right triangle, and if I know two sides of a right triangle, I'm looking for the third, I use the Pythagorean theorem. So I go 6 squared plus 11 squared equals x squared. So I get 36 plus 121 equals x squared. So I get here a 157 equals x squared, and you take the square root of it. Now, the cool thing is on this homework, they say go to the nearest tenth, okay? So if I'm going to the nearest tenth, that means I'm going to punch it in here real quick. And you should get, when you punch it into your calculator, about 12.5. Remember, square root of 144 is 12, so that logically makes sense for us. Hopefully that will give you an idea of kind of what we're doing there. Another one I want to show you that I just think is a blast is like number 18, and we're looking for the measures of the arcs. And I'm going to show you how easy this is. So look at number 18, and if we mark up our diagrams, I promise, guys, it's so helpful for us. So let's go here to our diagram. We have A, B here. So here's A, B, and we have our center O, but they show something here, and I think it's kind of cool if we remember something here. We want to know the measure of arc AB, okay? And with arc AB, it'd be really nice if I knew the central angle. So the first thing I'm going to do is I'm going to draw in my other radii so I can form my angle. Because if I know the angle, I know the degree measure of the arc. But looking at this, I'm like, I'm still stuck. I don't know what to do. Well, yes you do. What type of triangle, right triangle, has two congruent legs? You should have a 45, 45, 90. Well, if this one's 45 degrees, and these will end up being the same because this radius will, look, bisects the chord because it goes from the center, it's perpendicular to the chord. Oh, look, that's another 45, 45, 90. Oh, that whole angle now is 90 degrees. And that means the measure of my arc in degrees is 90 degrees also. So it's really kind of cool how it works. But also remember, like on number 17, it says congruent arcs, chords have congruent arcs. Well, okay, so that means my arcs, my chords are both 16, so that means arc CD and arc AB are both 108. So that's the type of stuff you can use. I was trying to see if anything with 30 and 31, I think we might want to look at those real quick, and then we'll be done recording on this one. On the homeworks, you have to do 30 through, make sure I got this right, 30 through 32. So let's draw our diagram real quickly here. It says circle A and circle B are congruent, and circle CD is a chord of both. So first of all, they're congruent chord circles. So let's see if I can draw this well. Okay, and here is A, here is B. If they're congruent, what do you know about the radii? You better know, okay, that they're congruent. So here's CD, and this is for 30 through 32, the diagram. Now, here's what's really cool. If that's the case, I'm going to draw a segment from the centers, okay? And I'm going to draw in the radii of each. And I know those radii are congruent. And I'm going to draw it in because they're congruent circles. All right, now looking at this, not trying to be like all flippant or anything like that, but what type of quadrilateral did you get? A rhombus. Yay. What do we know about the properties of a rhombus? Look what else do I have drawn here. I have the diagonals. And the diagonals of a rhombus are what? Perpendicular. They bisect each other. I mean, you have so much stuff you could use here. And they bisect opposite pairs of angles. So all that stuff can help us. So like for instance, they want to know how long is the radius. Look, for instance, they go segment AB. This whole segment is 8. So this is number 30 specifically. If it's whole 8, I know this would be 4 because they're both going to have to be 4. Then they tell us the length of segment CD is 6. Okay, so this is 6, but oh, it's bisected, so that's 3. Oh, look, a 3, 4, 5. So the radius are what? Is what? The radii equal 5, and it'd be 5 inches. Simple as that. But that's because I knew the diagonals of a rhombus are perpendicular. And you're going to use the same type of stuff when you're working with these. So let's just see. I would love to do another one on 31. So guys, give me a moment. I'm going to flip the paper around. Do the same thing real here. 31. I got my 2 congruent circles. I know here's segment C and D. And we have A and B. Okay, and because we know the radii are all congruent, because they're congruent circles, I got a rhombus. We know that they're perpendicular bisectors. So let's see which pieces of information they're going to give us here. They tell us AB is 24 centimeters. AB is 24 centimeters, so that means it's bisected. This would be a 12, and a 12 here. They tell us the radius is 13 centimeters. And they want to know the length of CD. How long is segment CD? Oh, look. What do we have? Blank 12, 13. 5, 12, 13. Well, segment CD's length is 10, and I think they said in centimeters. So hopefully, I didn't do 32. I want you guys to play with that one on your own. But this, all you have to do is mark up the diagram and use it to your advantage.